So we all know that a right triangle has one right angle, and often we call it angle C. So if we have triangle ABC, typically we would use C to represent the right angle. We would call the sides that form the right angle the legs. So A and B are called the legs. And then the side that's opposite our right angle we call the hypotenuse. And the hypotenuse is always going to be opposite your right angle. And when we say opposite, we mean across from. One thing to note is we utilize capital letters to indicate angle measures, and we use lowercase letters to indicate side lengths. So whenever you see them talking about capital A, they're talking about a measure of an angle, versus lowercase a, they are talking about a measure of a side length. Okay, so let's talk about, let's name angle A this Greek letter theta, and we're going to be talking about the different trig ratios of theta. So there are 6 trig ratios. There's sine, cosine, tangent, cosecant, secant, and cotangent. These 3 are the primary trig ratios, and then cosecant, secant, and cotangent are what we call the reciprocal trig ratios. So sine is represented by the ratio the opposite side divided by hypotenuse. So what we would do is we would look at angle theta. The side opposite angle theta, this is the opposite side, is A, and then the hypotenuse is side C. So it's going to be A divided by C. The cosine is represented by the adjacent side divided by the hypotenuse. So the adjacent side is the side that forms the angle theta that is not the hypotenuse. So that would be side B divided by the hypotenuse, which is side C. The tangent, so this is the adjacent side. The tangent is just the side opposite, right? So this side opposite divided by this side adjacent, so it's A divided by B. A divided by B. The cosecant is the reciprocal function of the sine. So to get the ratio for cosecant, you just take the reciprocal of the sine ratio. So it's going to be the hypotenuse side divided by the opposite side. So it's going to be length C divided by the length A. The secant is the reciprocal of cosine, so it's the hypotenuse divided by the adjacent. So that's going to be C divided by B. And lastly, the cotangent is the adjacent divided by the opposite. That's the reciprocal of tangent. And so it's going to be B divided by A. So often we'll be asked to find the various measures of the trig ratios, and this is what you're going to be looking for. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for the 3 main trig functions, we have this mnemonic device that can kind of help us remember the ratios, and it is SOHCAHTOA. I'm sure you've heard it before. So the SO is telling us that it's the opposite divided by hypotenuse. The CA is telling us it's adjacent over hypotenuse for cosine, and TOA is telling us for tangent it's opposite divided by adjacent. And then you just have to remember the reciprocal functions. You would just take the reciprocal of those ratios. All right. Let's take a look at some additional properties and relationships in right triangles. The first one we're going to look at is the relationship between the 3 sides of a right triangle. It's a pretty famous theorem credited to someone called Pythagoras, and it says the sum of the squares of the 2 legs of a right triangle is equal to the square of the hypotenuse. Basically, it just says square your legs, add them together, it equals the square of the hypotenuse measure. This is the Pythagorean theorem. Pythagorean theorem. There's another theorem in all triangles, not just right triangles, that says the sum of the 3 angles in a right triangle sum to be 180 degrees. So this is kind of a corollary to that theorem. So if we know that angle C is our right angle and its measure is 90 degrees, then since all 3 angles have to sum to 180, then the sum of A and B must sum to the remaining measures of the triangle, and since 90 degrees are already accounted for, the sum of A and B must also sum to 90 degrees. So the two angles that are not the right angles sum to 90 degrees, which is the measure of our right angle. Okay, so let's go ahead and do some examples. So we have this triangle here. It is asking us to find the exact value of the 6 trig functions. So that means they don't want us to plug it into the calculator to get a decimal value. They just want to know the fraction. So for sine, we need to know the opposite, right? So it's so we need to know the opposite and the hypotenuse. We have the opposite, we don't have the hypotenuse. But we can get the hypotenuse. We can use Pythagorean theorem. So Pythagorean theorem says square your two legs, so 5 squared plus 12 squared, and that should equal the, if you add those together, it should equal the hypotenuse squared. So that's going to be 25 plus 144 equals c squared. 25 and 144 is 169. Take the square root. Typically you would do plus or minus, but since we're dealing with a length, we're just going to utilize the principal root, which is the positive square root. And so we would get that the hypotenuse is 13. So the length of the hypotenuse is 13. So for the sine, it's going to be side opposite over the hypotenuse. So that will be 5 over 13. The cosine is going to be the adjacent over the hypotenuse. So that will be 12 over 13, right? Because it is the ka part of SOHCAHTOA. And then lastly, tangent is the opposite over adjacent. So the opposite angle, the side opposite theta is 5. The side adjacent to theta is 12. Cosecant, it's the reciprocal of sine. So all you would do is take the reciprocal of the sine ratio. So you would get 13 over 5. Secant is the reciprocal of cosine. So you'd get 13 over 12. And cotangent is reciprocal of tangent. So you would get 12 over 5. So if you know the 3 trig ratios, finding their reciprocal function ratios is pretty straightforward. Just take some reciprocals. In this example, it says use the given information to solve the triangle. When it says to solve a triangle, basically what that means is find all remaining sides and angle measures that are not given. We want to round the length to the nearest hundredth. So any side lengths will round to 2 decimal places, and round your angle measures to the nearest degree. So angles to 1 decimal place. So we have triangle ABC, or I'm going to call it triangle ABC. They give me angle A and they give me angle B and side B. So I'm just going to call the other 2 sides A and C. I'll call this B, this one A, and we'll use the conventional C for the right angle there. I know the measure of angle B is 20 degrees. Side B is always opposite angle B, so that measure there is 5. So I need to find the measure of angle A, I need to find the measure of side A, and I need to find the measure of side C. So I'm missing these 3 measures there, so those are what I'm going to find. The measure of angle A, by that one corollary that we were talking about, is just going to be 90 degrees. Wow, that was terrible. 90 degrees minus 20 degrees, because angle A and angle B, they should sum to 90. If I already know that one of them is 20, then the other must be 70. So the measure of angle A is going to be 70 degrees. I want to try and find side A next. To find side A, I'm actually going to use a trig ratio. So I know angle A is 70. I know this side here, and I know this side here. Those 2 sides relative to side A are the opposite sides and the adjacent sides. The trig ratio that utilizes the opposite and adjacent is going to be tangent. So I'm going to use the tangent of angle A. Oh, don't want to move that there. I want this down here. So it's going to be the tangent of angle A, but angle A has a measure of 70 degrees, is going to equal the opposite side length divided by the adjacent side length. Now I'm trying to find A, so I'm going to multiply both sides by 5. So 5 times the tangent of 70 degrees would be equal to A. Now we need to then use our calculator to evaluate this. It wants this angle, it's a side length rounded to 2 decimal places. When you're calculating this, you need to make sure that your calculator is in degree mode, because we are using degrees here. So 5 times the tangent of 70 is going to end up being, so that would mean that A is about 13.74 units. So the measure of side A is 13.74 units. Now to get side B, actually I have side B, to get side C, I could use Pythagorean theorem, this squared plus this squared equals c squared, or I could be a little bit more precise and use some of the given information that I know to start to find the measure of angle B. That's probably the best route to go because you're not going to have rounding error associated with the measure of side A, because we had to remember this is a rounded measure. But based on our rounding, it's probably not going to be too far off if we use Pythagorean theorem either. So either way works, but just know that if your answer is off by a little bit, by a few like hundredths, it might just be due to rounding error using a non-exact value. So let's find side C using maybe angle B. Angle B? Yeah, let's do angle B. So if I do angle B, I know that the measure of angle B is going to equal, I could use B, this side, and this side. So doing that, I'm using the opposite side and the hypotenuse. So opposite side divided by hypotenuse is sine. So if I say sine of 20 degrees is equal to 5 divided by c, I can try and isolate c by, if I multiply both sides by c, it'll be c times the sine of 20, and then I would divide by the sine of 20. So that's going to be c is equal to 5 divided by the sine of 20 degrees. And that's going to be roughly 14.62 units. So the length of side C is 14.62 units. If you used Pythagorean theorem, you would probably get a measure that is pretty close to that, if not exactly that when rounded to two decimal places. Okay, let's look at one last example. So this looks like the same triangle, so note these triangles are not drawn to scale. We're just kind of using the same shape. So side A is 5, side B is 3. So I'll call this side A, or angle A, this B. Again, we'll call this C the hypotenuse. So this is 5, this is 3. We need to know side C, and we need to know the measure of angle A and the measure of angle B. Those are the missing values, and that's what we're looking to find. Let's find side C first, side C. And we're going to use Pythagorean theorem. So side C is, so c squared equals 3 squared plus 5 squared. So c squared equals 9 plus 25. So c squared is 25 and 9, that's 34. Meaning c is the square root of 34. Now when possible, it's usually nice to use an exact value, but these do ask us to round to hundredths. So if you plug this in your calculator, it's going to be about 5.83. But I would utilize the square root of 34 as much as possible because it is an exact value, right? It's not a rounded measure. And I can use that when calculating things like my measure of angle A or measure of angle B. Let's go ahead and find the measure of angle A. So we're going to do that next. So if I'm using the measure of angle A, I can choose to use something like tangent, which would utilize the opposite side and the adjacent side. Or I could use something like sine, which would use the opposite over hypotenuse. Or I could use cosine, which would be this over the hypotenuse, the adjacent over hypotenuse. Doesn't really matter. Let's use cosine. So the cosine of A is going to be the adjacent side, 3, divided by the square root of 34. And this would be where you would want to use the square root of 34 rather than 5.83. If you don't want to use a radical or you don't want to use a rounded measure, then you can just use tangent because those two values are exact. But this works. Now, I'm trying to get a measure of an angle out of this. So I have a ratio, but I need my angle measure. So in order to do that, I have to actually utilize an inverse trig functions. So I'm going to take the inverse cosine of both sides. Now, if you recall back in chapter 5, we talked about inverse functions. And when you compose a function with its inverse, you get the argument as a result, which means in doing this process, I'm going to get a out. And a is going to equal the inverse cosine of 3 over the square root of 34. To get the angle measure, you're going to take that, plug it into your calculator, and you would find, we're rounding to the nearest degree, so actually we're not going to round to any decimal places. We're going to go round to the nearest whole number, and you get that this turns out to be roughly 59 degrees. So angle A is about 59 degrees. And then that means we can find angle B by subtracting that measure from 90. So 90 minus 59 is going to be 31. So angle B would be about 31 degrees.